Hello, algebra, as I get my paper a little straighter here. Today we're going to be talking about how do we solve these inequalities, right? We've already looked at writing them and graphing them, but how do we solve them? And the easiest thing I can tell you to do is what one student told me. He said, I pretend that this inequality symbol is an equal sign, and I solve it. And then I look at the inequality, and the only time I have to have an issue is when we multiply or divide by a negative, which we'll get to in the next lesson. So I do want you to know that we use the properties of equality to solve equations and inequalities. So whatever we do to one side, we have to do the other still. That hasn't changed. And equivalent inequalities are equalities that have the same solutions. So x could be greater than 2, y could be greater than 2. Those are equivalent inequalities. We know that they mean the same thing. So let's actually try solving some of these and graphing them. So right here we've got x minus 6 is greater than or equal to negative 10. We need to think about what the opposite of subtraction is, which is going to be addition. So let's add 6 to both sides. And so now that zeroes out. So I have x is greater than or equal to negative 10 plus 6. If it helps you, I think of this as like they're having a war, a battle, two different armies, right? We've got the negative army and the positive army. So when they fight each other, we end up with 4 of our negative guys left over. So we have a negative 4. So x is greater than or equal to negative 4. Well, I always start with an open dot, the number I care about. In this case, it's negative 4. And then because we have this equal to, it fills in our open dot, right? And then we want to do where it's greater than. So if I plugged in, this would be negative 3, and this would be negative 5. If I plug in negative 3, is negative 3 greater than or equal to negative 4? Yes, that's true. So that means I want to shade to this side. So I want to shade this direction. Some of you like to think of it as which way is the inequality pointing, but remember that only works if your variable is on the left side. It only works if your variable is on the left. So let's solve this one now. We have b minus 2 is greater than or equal to negative 9. Opposite of subtract is to add, so I'm going to add 2 on both sides. We have b is greater than or equal to negative 7. That means this guy right here is negative 7. Again, it's got that less than or equal to, greater than or equal to. That equal to is what fills in our circle, and we want to shade to the greater side. So it's going to be this direction, which is going to be towards negative 6. So now I'm going to move the page. Let's take a look at some decimals. I know you prefer them over fractions. So we have 1.4 plus m, and this is greater than negative 8, or negative 8 is less than 1.4 plus m. However you want to say it, it's the same. I noticed some errors when we have a number like this. We have to think about, is this a positive or a negative number? Is it a positive or a negative? It's a positive. What's the opposite of a positive? Subtraction, negatives. So 1.4 is going to be subtracted on both sides, not added, okay? That's the mistake I commonly see, is I'll see a plus 1.4, but we want to subtract it so we can cancel it out. So that means we are left with negative 9.4, which is less than 0 plus m. I'm going to rewrite this for some of us who like to have our variable on the left in just a minute. So for now, I'm just going to put down our negative 9.4 down here. This would be negative 9.3. This would be negative 9.5. Remember, it's better to only owe $9.30 compared to $9.50. So we get bigger going to the right. So I'm going to do an open dot here. Do we have an equal to? Nope. So it stays an open dot. And then we have to decide which way to shade. So if I plug in 9.3, is 9.4 less than negative 9.3. Is that true? Yes. So this is the direction we want to shade. For those of you who like writing the variable first, we have m is greater than negative 9.4. Either way it works, right? But you can see that it's pointing in that direction. Do one more before we look at some word problems. And this one has a fraction in it. So we've got z plus 1/6. We want to get z by itself. In order to get z by itself, I need to subtract 1/6 on both sides. So now we have 5/6 minus 1/6 is less than or equal to z. Now here's the key thing. If these have the same denominator, we can just subtract the numerators, right? So that would be 4/6 is less than or equal to z, but 4/6 is really I can divide 2 on top and on bottom, right? I can factor him out because he's really 1 if we have 2 over 2. So we are left with a 2 divided by 3 is less than or equal to z. So I'm going to do 2/3 here. And then on this side, we would have 1, and on this side, we would have 1/3, and then there'd even be a 0 down there. You could write this as 3/3 if you wanted to. It doesn't matter, right? It's all the same. I'm going to start with an open dot here. It's an equal to, so I shade it in. And now I need to figure out which side is going to be true. So is it going to be the 1/3? So is 2/3 less than or equal to 1/3? Or is 2/3 less than or equal to 3/3 or 1? This is going to be the true side. So that means I want to shade this direction. Let's take a look at a word problem. Ooh, there we go. So a circuit overloads at 1800 watts of electricity. All right, 1800 watts of electricity. You plug a microwave oven that uses 1100 watts of electricity into the circuit. We want to write and solve an inequality. Well, we know that our total watts cannot be more than 1800, right? So that means it can be less than 1800. Can it be equal to it, though, is the question. Can it be equal to it? What do you think? No. If it hits 1800, then it overloads and the circuit blows. So it cannot be equal to. So it has to be less than. So we want to have everything on the circuit. So our total we know is 1800. It needs to be less than. Well, what do we have on the circuit? We have a microwave oven. So that uses 1100 watts. And we have some other appliance, right? We're going to have some amount that we can also plug in. So we want to solve this. So first thing we want to do, we need to move this 1100 to the other side. Well, it's a positive 1100. We need to subtract 1100. So we are left with x is greater than, this zeroes out, 1800 minus 1100, is 700. So we need to have an appliance that is less than 700. It can't even be equal to it, right? It has to be 699. That's the best that we can do. So we can plug in an appliance that is less than 700 watts. If we look at our little chart here, that means we could plug in the blender and the clock reader. Or clock radio. So there we go. I hope that helps. I hope it makes sense. Email me if you have questions. In case you're wondering how you would graph this, we've got our 700 here. It'd be an open dot, and we are shading this direction.